Welcome back. This is 1.4a. The objective here is to determine one-sided limits. So we're looking at this notation right here, the limit as x approaches c from the left. It looks like a little negative symbol, meaning it's coming from the negative side. This is the limit from the left. And the reason of the negative in that notation, meaning it comes from the negative side, versus this one with the little plus sign means the limit from the right, or coming from the positive side if we're thinking about the x-axis. And we say that the limit of a function exists as x approaches c, not from the left or from the right. That means from both sides, if and only if the limit as x approaches c from the left of that function equals the limit as x approaches c from the right of that function. Remember, we talked about before that they have to be approaching the same number from both sides. Let's look at some examples. Notice that we have g of 4. We have g of negative 4, x approaching negative 4 from the left, x approaching negative 4 from the right, and x approaching negative 4. Different ways to look at what's happening at negative 4. This one means the function value. This one means function value right here. So we're looking at what is the y value when x is 1, 2, 3, 4, negative 4. I see it's 1, 2, 3, 4, 5. There's a point right there. Negative 5 is the function value. Now that's different from saying what's happening as x is approaching negative 4 from the left. Well, the function is headed towards that y value of negative 5 as we come from the left, or the more negative x values. Then we look at the other side from negative 4 on the right. So looking at the function coming from the right of negative 4, we're up here on this piece of the function, and it's headed towards the y value of 2. Remember, it's not about whether it gets there or not. It does not matter that there is a hole right there. The function is approaching that y value of negative 2. Now, because coming from the left is negative 5 and coming from the right is positive 2, different values means the limit as x approaches negative 4 does not exist. That's because the limit as x approaches negative 4 from the left does not equal the limit as x approaches negative 4 from the right for this function. Why don't you go ahead and try the other examples, 5, 6, 7, 8, 9, 10, 11, 12. Pause the video, come back. All right, let's see how you did. G of 0, 1, 2, 3, 4 is negative 4. Coming from the left is negative 4. Coming from the right is negative 4. And because these are the same from the left and the right, the limit as x approaches 0 will be the same, negative 4. You can pause the video and try the other ones. G of 3 has a hole right there, so we're going to say that that one does not exist because of the hole that's there. As x approaches 3 from the right, however, as x approaches 3 from the right, the function is approaching negative 2. It may not get there, that doesn't matter. As x approaches negative 3 from the left, also the function's approaching negative 2. Therefore, even though there's a hole, the limit as x approaches 3 will be negative 2, since this guy and this guy are the same. Let's look at some problems that don't have a graph. Remember last time we talked about strategies for finding limits? You want to always try direct substitution first. Same thing goes even if it's a one-sided limit. It does not matter that that's from the left. Let's try direct substitution first. So I'm going to write the sine of pi over 3 to see is that function headed somewhere, and that does have a value. It's square root of 3 over 2. Done. Next one, if I try direct substitution, regardless of that that's from the right or from the left, I get 2 minus 2 over 2 squared minus 4, and there's our indeterminate form. We get 0 over 0. So remember, we think of other things. Next thing on our list is factoring. So if I factor the bottom, x minus 2, the denominator, I'm going to write my limit in front of that. I'm going to continue to write from the right, even though that doesn't have any effect on my plugging it in. Those cancel out, and now I get 1 over 2 plus 2, which is 1 over 4, and there we go. Doesn't matter that it's from the left or from the right. Now, if you remember this one, we had this example when we looked at a graph a couple sections ago, and we saw that this limit doesn't exist. Now, we always try direct substitution, but if it's an absolute value, we cannot just plug it in. So we're going to have to break this up. We are going to have to write this absolute value of x minus 3 over x minus 3 as a function in two parts, or a piecewise function. So remember, if we take away the absolute values, it's possible that it's a positive expression, or it's possible that it's the negative of the expression. Now, the denominator doesn't have absolute values, so it will stay x minus 3 in both cases. Now, when is it positive and when is it negative? When is it the positive of x minus 3 and when is it the negative of x minus 3 after taking away these absolute value symbols? Well, remember that absolute value graph, we look for where that vertex is, and that's by setting that stuff in the absolute value symbols equal to 0, solving for x, that's where that switchover is going to be. So when it's positive, that's when x is bigger, greater than 3, negative when x is less than 3. Now, we can't say equal to in either of these situations because that would make the denominator 0 if x equals 3. So both of those have to stay unequal, just greater than or less than. Now, if we simplify those expressions, the top expression gives us positive 1. The bottom expression gives us negative 1. So I'm going to rewrite this as 1 for x being greater than 3 and negative 1 for x being less than 3. Now, x being greater than 3 are the more positive values. So this is saying from the right of 3 versus this one is saying from the left of 3. So if we look at what we're asked for the limit as x approaches 3 from the left of our function. So looking at how we broke it up, we can see that we're looking for from the left, so that's going to be this one right here of negative 1. If we were to graph it, it's going to be like those graphs that we saw where here's 3, and from the left of 3, it's down here at negative 1. There's a hole, can't equal 3, and from the right, it's up here again, a hole.